Hello everyone, this is Rajiv Sunaki, Department of Civil Engineering, Jain Polytechnic, Belgavi. So today we will be continuing with the Unit 5, that is design of staircases, but it is further divided into another portion, that is design of lintels. So in design of lintels we will be covering two lectures today, that is lecture number 46 and 47. So the content in this lecture are: what is a lintel, bearing of lintel, types of design loads on lintel, and design steps. So coming to what is a lintel is a structure made of wood, concrete or stone which is provided above the door or a window. It's a horizontal structure above the opening. It takes load from the wall and it distributes to the side of the walls. These are easy to construct as compared to arches. So in this image you can see a RCC lintel. Now bearing of a lintel. The bearing provided should be the minimum of the following three cases. First, at least the bearing provided should be 10 centimeters on both sides. Height of lintel beam 1/10 to 1/12 of the span of the lintel. So here in this image you can see a lintel over opening and the bearing provided which is projected beneath the wall. Types of design loads on lintel: self weight of the lintel, dead load of the wall above the opening, dead load and live load transferred from the roof. So coming to a problem. So before that we should be aware of design steps. So here, while designing a lintel, the effective depth should be assumed, that is D is equal to L by 10. Overall depth is equal to effective plus effective cover. So the overall is equal to effective depth plus the cover, that is 50 mm. Width of lintel, it may be taken as 230 to 300 mm. Effective span should be least of following two: clear span plus bearing is equal to clear span plus effective depth. Load and moment calculation: transfer of loads to the sides by arch action, height of wall above lintel. Effective span, thickness of masonry, rho m is equal to density of masonry, that is 19.2 kilonewton per meter cube. Moment due to masonry, m1 is equal to wl by 6. Self weight of lintel, b into d into density of RCC. Therefore w is equal to the whatever self weight we get. Moment due to self weight, m2 wl square by 8. Total bending moment is equal to both, that is m1 and m2 you add, you get total bending moment, and ultimate we have to mu is equal to multiply it into 1.5. Next is check for depth, that is ultimate moment of resistance using these equations as per the Fy provided. So after substituting the values, we determine the tension reinforcement using this equation and determine the number of bars and the mm of bar which we should provide. Next, coming to the design of shear reinforcement, which is very important. It is denoted by V, that is shear. It is further calculated by the equations, that WL by 2 plus W by 2, we get shear force. and for ultimate shear we use VU is equal to V into 1.5. Next, shear stress, that is tau V, percentage of steel. We determine all these values by using IS 456 2000, and the value of tau C is taken from table number 19. Thank you.